All right, guys. So we're going to do the fiber notes today. This will be the last bit of notes. So if you have not done some of the notes from last week, I would quickly do them because I will be taking a note grade right after this one. So this will be our last set for the hair and fiber notes. Let's see. Let's make this bigger. After this, we'll have some practice on Wednesday and then review and test. So we'll be moving on. Most of the unit is hair, just a little bit of fiber now. Okay. Oh, I forgot. I don't like when it's set up like this. Oh, well. So because textiles are mass produced, they are considered class evidence. So just the same way most of the time hair is considered class because we can't directly pinpoint it to one person. Our hair is too similar to each other usually. So is fibers because we can all buy the same clothes in the same places for the most part. So it's pretty rare when someone is wearing something that truly no one else could have had. So being that most of our clothes are mass produced, rugs are mass produced, cars are mass produced, like all the stuff that would have fibers attached to it, pretty much all the time fibers are class evidence, not individual. It is difficult to trace a fiber back to a specific source, yet fiber evidence is still important evidence because it creates links between victims, suspects, and locations. So same way as hair, most of the time it is not going to be enough evidence if that's all you have in the case is there's some matching fibers, but it certainly adds to the case. It's certainly a valid piece of evidence. It's just usually not the biggest piece. Fibers can come from clothing, coats, carpet, furniture, curtains, bedding, insulation, rope, etc. So all those things can have fiber attached to it. Now, fibers may be transferred directly from the victim, suspect to the victim. This is called direct transfer. So like, suspect touches victim, transfers fibers onto them. Or victim is crawling around in the trunk of a car, gets the trunk fibers on them. That's directly touching them. It's direct transfer. However, an individual may also have fibers on them that they picked up from their environment and then transfers to the other person during contact. So that'd be secondary transfer, just like with hair. So an example, they're wearing, or maybe they're in their car seat. Okay, so the suspect drove his car, and then when he gets to the house to commit the murder, he then leaves some of the fiber from his own car in their bedspread as he attacked the person. Okay, so that would be a secondary transfer. That bedspread never touched his car, but he touched the car, had the fibers on him, and then touched the bedspread. So now it's on the bed. So that's secondary. This is just a case kind of showing you all the different places that have had fibers like from them that you can get. Like, I guess it's mostly just kind of show you that most people don't think how easily we transfer fibers because we really do. Every time there's any kind of touching, like we generally transfer fibers to one another. So this 18-year-old male here was stabbed to death in an unprovoked attack by a gang of white youths. It was believed to be a racist attack as he waits at the bus stop in Southeast London with his friend. Tiny fragments of new evidence emerged in 2007 as scientists conducted a massive cold case review. So, 1993 to 2007, this was an old case. So it was just very exciting when they finally we had better microscopes and they could better examine these fibers. They re-examined clothing taken from two defendants, Gary Dobson and David Doris, starting a process that eventually led to a guilty verdict in 2012. So 1993 to 2012, these two men were convicted of their murder just because of the jacket that he was wearing that was found on his clothing. Same thing, the shirt he was wearing was found on his jacket. Jacket underneath had even fibers underneath and on top of his jacket. So just all the fibers were cross-laced, proving that they must have had an altercation together. Early collection of fibers is critical. Most fiber evidence, 95%, falls off or is lost from a crime scene in 24 hours. Now, if you're in a more concealed environment, like inside the car that's showing in this picture, the fibers might be held better because they're inside the car. If no doors have been opened, you're the first person inside the crime scene of the car, more likely to find it. But certainly if it's outside, fibers they just blow away. So even if the body was laid out, the fibers that were on the body were probably going to be disturbed, as the body would be disturbed through decomposition, through animals eating it, through wind, rain, all that kind of stuff. So basically, you can't really trust fiber and hair evidence if you get to a crime scene late because fibers can be moved around. So I can't say for certain if it's been 5 days that the fiber found on their sleeve, did it start on their sleeve or did it get blown onto their sleeve? Like, it's hard to say if it's been that long of a time. If you get to a scene fast, though, then you can trust where it's at. When using fiber as evidence, forensic scientists want to determine the following: type of fiber, composition, and uniqueness. So we want to know what kind it is, like cotton, silk, wool, acetate, nylon, that kind of thing. Fiber color, obviously. That can be really pretty specific, especially if the dye that was used was really specific by the company. Maybe they have a patent, like only that company can make that kind of dye. That would be very helpful. So sometimes the color can actually be really helpful. You saw that in the video we watched on Monday with the poor little girl's sweater color. The dye on it was so specific that it made it to where like no other blue fiber could be that one. Like obviously that Big Bird sweater was inside his car. Number of fibers found. Being that we lose fibers so easily, if you only find one or two, that could be pretty random. Same thing as hair. We lose hair so easily. But if there's a lot, if there's several of the same fiber in that same area, then it's like pointing to the fact that it probably is because they had some kind of altercation. Certainly the more fibers found, probably the more violent the crime was. Where the fiber was found can place the suspect at the scene or to the victim. So same thing, they placed the girl inside his car. He had to have taken her somewhere because her fibers were inside his car. So puts a place to where the suspect or the victim was. Say like maybe if they put them in the trunk and they find the fibers in the trunk, okay, well now we know even if he didn't admit that the body was in the trunk. Textile fiber originated from what is the source of the fiber. That can just help pinpoint if that's truly their clothing, if we can figure out where the clothing is from. Are there multiple types of fiber? Several types of fibers can be more supportive because if we can find, most of our clothes, like this one probably is all made of the same fibers, but there's lots of sweaters that have several different kinds and a jacket would have several different kinds of fibers. And if you find all three and they all match that one jacket, it's more supportive to your evidence. Type of crime committed. If a forensic scientist know the crime, they have a better idea of what kind of fiber transfer to look for. Examples, for rape, we have a better idea of where to look for it. Kidnapping, breaking and entering, you're looking for at where they broke in. They're probably going to leave some fiber evidence behind. Time between crime and fiber discovery. Again, the sooner you get, the better evidence it is. If it's been a long time, fibers do move around really easily. Then collection of fibers. This is the same way as we would collect hair. You're going to do a visual search first. Use forceps, which are basically like big metal tweezers, or sticky tape. So you're picking them up because I can literally see it. I'm taping. If there's carpets, any kind of carpet or fuzzy area, I can just be taping the whole area. And I can also vacuum. The problem with vacuum is though, if I vacuum a whole carpet, I don't know exactly where that hair came from. I just know that it came from this carpet. Whereas if I'm taping, I can literally tape a square area, package it up, and like if I find a hair or a fiber on that, well, I know exactly which square floor it came from because I would label it. So more helpful to be picking it up or with tape, but if you're running out of time, you can vacuum. Each garment should be laid on a clean sheet of paper and separately rolled up in the paper. Bag clothing items individually in paper bags. So like never bag, like even if it's all the same person, it's all the same clothes they're wearing, their pants, their shirt, their jacket, their socks. All of them should be bagged differently because I want to know where that fiber was at. Was it on their shirt? Was it on their pants? Was it on their socks? Because all that could be telling me a slightly different story of what occurred. Recording where fibers were found is critical for evidence to be admissible in court. So again, doing your very best to be as tedious as possible always makes it look the best in court. Control samples are also important. Known samples should be taken from all possible sources for comparison. So if we know what they were wearing, obviously we should be collecting those. If we get to the house and we know it's been really soon, that's our suspect, and they allow us to take some of their fibers from their clothes, awesome. Definitely want to take as many control samples as you can. Testing fibers. So these are just some different ways that you can test fibers. First way is microscope. Way we did it with hair. You just literally look at it under a microscope. If there is limited amount of fiber found at the crime scene, it is important to not destroy your evidence. So a lot of the fiber tests destroy it. Microscopes don't. I can look at it over and over and over again. So that's an easy test. Simple, doesn't destroy the evidence. Two non-destructive procedures would include polarizing light, so allow scientists to look optical properties of fiber using different wavelengths of light. It could help us tell about the dye. Okay, so that would be telling us if the dye matched using polarizing light microscopy. And then infrared spectroscopy allows scientists to see chemical structure of fiber using beams of light. So just a little more information, what is the actual chemical composition of the dye? Because most fibers have a dye, have a color. Now, if I have a lot of fibers, like they found 50 fibers at the crime scene and they're all similar, then I can do some different types of tests that are destructive procedures that will destroy the evidence, but will give me some information as they're being destroyed. So burning can tell us melting points, odors, ash, basically getting us to understanding what kind of fiber it is, because different types of fibers burn in different ways. Different types of solvents, so that's dissolving the fiber. So there are some types of fibers that will dissolve and some that won't. Staining, how well they stain, how well they absorb color, the density of the actual fabric, and the chromatography. This is also separating the dye. You've seen this done with pen ink before in class. You could also do this with fiber dye. Now, for these burning, solvent, staining, density, like all that it's just to help me determine what kind of fiber it is. So silk, polyester, cotton, these are all being burned, and look how they burn completely differently. If large quantities are found, so again, we can do the burning. So this is just kind of pointing out a little more detail about burning. This is a chart. This will probably be helpful for you to have in a future virtual lab you're going to do. Wool, all these things burn, but if it is a synthetic fiber, which we'll talk about more in a second, synthetic means man-made, nylon, offlin, polyester, acrylic, all those are man-made fibers. They're basically plastic and they melt. So if you try to burn them, they don't catch on fire. They literally burn like this. They turn into like a drippy mess. Whereas more natural fibers like wool and silk tend to actually burn and smell like burning hair, because that's kind of what it is. Wool is hair. Wool is sheep hair. Now for solvents, a fiber can be placed in a chemical at a particular temperature and the solubility will confirm the type of fiber that it is. So again, fibers that are more man-made, the synthetic fibers tend to dissolve, whereas natural fibers don't tend to dissolve. So kind of doing those chemical tests. So again, you'll kind of see in our little virtual lab. And then staining, so this is how the dye process is done, is all these things in this list, were dyed with the exact same dye. And yet it was picked up as a different color based on the type of fiber that it was. So there are some types of fibers that just don't pick up color like this. It just doesn't. I dyed it with the same thing that these were dyed with, and it didn't pick up the color. And some things pick up color really, really well and get very, very dark. So the amount of color they pick up can tell you about the substance. I've mentioned this beginning of the year that most of the time, if you have things like a coat, a jacket, duct tape, most of the time that's class evidence because anybody could buy duct tape. Anybody could buy that coat. But if you can match them together, like a puzzle piece from what was found in the crime scene to what is found in the suspect's house or on the suspect's person, then you can say it's individual evidence. I can say it's individual instead of class. Because if this duct tape was found on our poor victim, and then we get inside the suspect's car, and the last bit of duct tape showing literally fits it like a puzzle piece, we can say, like, I'm pretty sure that this isn't just duct tape they happen to have in their trunk, which is already a little suspicious, but it's the duct tape that was used on this victim. All right, so now I've already been mentioning this, but the natural versus synthetic fibers, that is kind of the biggest thing I need you to know for this part of this unit is what is the difference between fibers that are synthetic and what's the difference between fibers that are natural. So fibers that are natural come from animals, plants, and minerals. Okay, so natural fibers from living things. Animals, plants, or minerals. Maybe minerals aren't living, but from things on the planet. Synthetic fibers are man-made. We had to make it. Okay, so as an example of a wool fiber, it looks like hair because wool is hair. And then synthetic, it usually looks very perfect, very round. It's man-made. So comparison and how they are different. You need to know these differences. Synthetic fibers are much stronger. That's why we make them. They're good for rope and things like that. Stronger than natural fibers. Unlike natural, synthetic fibers are not damaged by microorganisms. So if I leave a shirt outside is made of cotton, it can be eaten by all kinds of critters. It can decompose because it's a natural thing. It's a plant. But synthetic fiber, so like I leave a sweater out there made of nylon, nothing's going to eat it. It's basically plastic. Okay, so plastic doesn't degrade. It's not damaged by microorganisms. Synthetic fibers can deteriorate in the sun, though. Okay, so synthetic fibers that are man-made melt. Okay, they tend to have a lower melting point. They can actually be warped by just the sun itself. They have lower temperatures that they can accept heat for. Definitely don't want to be wearing a synthetic fiber if you're using anything that burns, because if you caught on fire wearing something synthetic, it would just melt into your skin and they'd have to get it off your skin, which would be awful. So that's always something that I tend to think about on lab days in chemistry. When I know we're going to be burning something, I always wear cotton. Cotton burns really fast. It burns off your body instead of burning into your body. You don't want to wear polyester or something like that because it melts into you. Under magnification, all synthetic fibers have very regular diameter. So synthetic, man-made, very round, very perfect, very weirdly man-made. Hairs, if it's from an animal, well, it's going to have a cuticle. It's going to have scales. It's going to look like hair, things we've talked about before. So you have this chart. Again, you can come back here when you're looking at your labs later. This is a helpful chart. Tells you what it smells like when you burn it. Tells you what it looks like when you burn it. How they're different. And that is it. Okay. So that is our fiber notes. We'll be doing some practicing later in the week, and then we'll be testing, and then we'll be done with this unit. All right.